On January 7th, 2026, astronomers across the globe were left in awe as a discovery shattered everything they thought they knew about the speed of interstellar objects. A new cosmic visitor, unlike anything previously recorded, was racing through our solar system at unimaginable speeds, 20 times faster than 3I Atlas, the previous interstellar object that had captured the attention of the world. This new object, dubbed Swift Delta, had entered our solar system with such velocity that it would soon be gone from our sight, a fleeting visitor in the vast expanse of space. Swift Delta was detected by a network of ground-based telescopes that continuously monitor the skies for any unusual activity. But when they first saw this object, it didn't fit the profile of a typical interstellar visitor. Comets, asteroids, and other cosmic debris usually enter our solar system in irregular trajectories, often influenced by the gravity of nearby stars. But this was different. Swift Delta's velocity was simply too high. It was moving at a speed that far exceeded the usual velocity of objects that pass through our solar system. And, unlike many of its predecessors, it wasn't on a course that would bring it back for another visit. This was a one-time journey, a cosmic visitor that would pass through our solar system and then be gone, perhaps forever. At first, astronomers thought it might just be another comet, one of many that wander through space. After all, comets are a common phenomenon in the universe, and they've been observed for centuries. But this object was moving too fast, far beyond the expected range for comets. It was travelling at a velocity that made it appear almost deliberate, as if it was on a mission, bypassing our solar system with an efficiency that didn't align with the behaviour of typical space objects. As Swift Delta approached our Sun, scientists began to pay closer attention, trying to understand its behaviour and predict its trajectory. What they found only added to the mystery. Swift Delta's motion was not random or chaotic, as most comets are when they pass close to a star. Instead, it appeared to be on a carefully calculated path, one that seemed to be controlled by some unknown force. For a comet, this was highly unusual. Comets usually exhibit erratic motion as they approach a star, their ice sublimating and their gas jets pushing them off course. But Swift Delta didn't display this kind of behaviour. It didn't fragment, it didn't lose mass in chaotic bursts. Instead, it moved with a precision that suggested intelligent design. The more data astronomers collected, the more questions arose. What kind of object was Swift Delta? Was it just an unusually structured comet, or was it something else entirely? Its speed, trajectory, and behaviour were all at odds with the expected characteristics of a typical interstellar object. Some scientists began to entertain the possibility that Swift Delta was not a natural object at all, but rather a probe or spacecraft sent by an advanced civilization. This theory was far from mainstream, but it was difficult to ignore the anomalies that this object presented. As Swift Delta made its way through the solar system, astronomers were left to contemplate its origins. Where had it come from? Why was it travelling so fast? And most intriguingly, was it a message from somewhere far beyond our understanding? These were the questions that would define the next stages of our exploration, and with each passing day, the mystery deepened. Swift Delta wasn't just a cosmic anomaly, it was a signal, one that could hold the key to understanding the true nature of space, and perhaps even life beyond our own world. Stay with us as we unravel the layers of this mystery, examining the data, the anomalies, and the strange behaviour of Swift Delta. The answers may be closer than we think, but they also may be more complicated than we ever imagined. The first clear image of Swift Delta was captured by an astronomer named Paul Craigs, who was using a relatively modest backyard telescope. What he saw sent ripples through the amateur astronomy community. What was supposed to be a fuzzy comet, likely a streak of gas and dust as comets are, was instead a clear, defined object with a smooth, reflective surface and a distinct blue glow. The object appeared controlled, almost artificial in its structure. It didn't look like a typical comet, nor did it display the messy, chaotic features we expect from such space travellers. Craigs, a seasoned astrophotographer, posted the image online, and within hours the astronomical community was abuzz. His image was drastically different from what the large professional telescopes had shown. The images from Hubble and the James Webb Space Telescope had depicted Swift Delta as a blurry, indistinct sphere surrounded by a coma of gas and dust. But Craigs's photo revealed something far more defined, a shape that, was both clear and symmetrical. In other words, it looked engineered. Initially, some observers dismissed Craig's image as a mistake, perhaps an over-processed image or an artifact of the equipment. However, as more images started coming in from other amateur astronomers using similar setups, they all reported the same thing: a sharp, almost artificial object, unlike any comet they had ever seen. The excitement was palpable. Here was a chance to witness something truly unique, an object that had entered our solar system at incredible speed, behaving in a way that didn't match any comet we knew. This wasn't just a fluke. The patterns emerging from these amateur observations suggested something far stranger than any comet. The more professional astronomers analysed the data, the more they were forced to reconsider their assumptions. Was this truly a comet, or was it something else entirely? The idea that Swift Delta might be a man-made object, perhaps even an interstellar probe, started to gain traction. But no one could explain how it could have travelled so fast, or why it was behaving with such precision. At this point, the mystery deepened. Swift Delta was not just another object passing through the solar system. It was a cosmic puzzle, and the pieces weren't fitting together in any way that made sense. For every new image, for every new observation, the possibility of it being a natural object grew slimmer. The behaviour of Swift Delta, its speed, its controlled movements, and its seemingly deliberate path suggested something more sophisticated. Could we be witnessing the first encounter with alien technology? Or was this an entirely new class of space object, one that we had yet to fully understand? As Swift Delta continued its journey through our solar system, one thing became clear. This was no ordinary comet. It was a harbinger of something unknown, a cosmic enigma that would keep scientists and the world questioning everything we thought we knew about space. Swift Delta's discovery on January 7, 2026, left the scientific community reeling. The object's velocity was so immense that it defied all prior models of space travel and celestial movement. Moving 20 times faster than 3i Atlas, it wasn't just another interstellar object gliding through our solar system. It was something different, something that prompted astronomers to question what they had long taken for granted. In the world of space exploration, speed matters. The faster an object moves, the more it challenges our understanding of physics and celestial mechanics. So, just how fast was Swift Delta moving, and why did this matter so much? In space, objects move at velocities dictated by the forces around them, mainly gravity, which influences their trajectory and speed. The laws of motion that govern comets, asteroids, and other celestial bodies have been well studied. Comets that pass through our solar system typically travel at speeds that range from about 30 to 60 kilometers per second. 3i Atlas, the interstellar comet that captivated scientists a year prior, moved at an impressive speed of about 90 kilometers per second. But Swift Delta, which was now passing through our solar system at a staggering velocity, was moving at nearly 600 kilometers per second. This mind-boggling speed was 20 times faster than 3i Atlas. The fact that Swift Delta was travelling at such an extraordinary rate raised immediate concerns. How was it capable of maintaining such speed, and where did that energy come from? At such velocities, objects typically experience significant deceleration from gravitational interactions with nearby celestial bodies. The gravity of stars, planets, and even smaller objects should have slowed Swift Delta down long before it reached the inner solar system. Yet, as Swift Delta continued on its path, it showed no signs of slowing, no signs of the usual cosmic friction or gravitational forces taking their toll. This was the first real clue that something about Swift Delta was different. As it passed through the outskirts of the solar system, it didn't act like a typical comet. It wasn't exhibiting the usual slowdown or dispersal of gas and dust. Instead, it seemed to glide effortlessly, its velocity unimpeded by the forces we expect to encounter in space. Swift Delta wasn't just moving fast, it was maintaining that speed with remarkable consistency. It wasn't fragmenting, and it wasn't breaking apart like most comets would when subjected to intense solar radiation. For all intents and purposes, it was a cosmic anomaly. As astronomers tracked its movement, the questions mounted. How was Swift Delta able to sustain such velocity without external propulsion? A natural object, be it a comet or an asteroid, would typically decelerate when moving so quickly through space, especially as it passed through gravitational fields. interacted with solar winds and felt the effects of the sun's radiation, the data didn't add up. Swift Delta, on the other hand, seemed to be defying the laws of physics. The velocity it maintained was, quite frankly, impossible by current standards. It was as if this object had no need to obey the typical rules of celestial mechanics. So, the natural question arose, was it possible that Swift Delta wasn't a natural object at all? Could it be something engineered? Some scientists began to speculate that Swift Delta might be an artificial spacecraft, perhaps an alien probe travelling through the galaxy. But this wasn't a simple theory. It was a theory driven by evidence. The velocity of Swift Delta was one piece of that evidence. It wasn't just its speed that was unusual, but the way it maintained that speed without any observable deceleration. In the world of interstellar objects, this was unheard of. No known comet or asteroid could achieve such velocity and continue on an uninterrupted course without some kind of external force or advanced technology involved. As the days passed and more data came in, the mystery deepened. Some researchers pointed to the possibility that Swift Delta had somehow harnessed the energy from its surroundings, using an advanced propulsion system that could sustain its incredible speed. Others suggested that the object might be taking advantage of the gravitational slingshot effect, but at speeds far greater than any spacecraft we've sent to date. Whatever the explanation, it was clear that Swift Delta's velocity was no accident. There had to be more to this object than just natural forces at play. As the scientists and researchers continued to gather data, one thing became increasingly clear. Swift Delta wasn't just another passing comet. It was something far more profound, something that challenged our understanding of space, technology, and the very forces that govern our universe. The speed of this interstellar object was not just a curiosity, it was a sign that something much larger and far more mysterious was at play. What could explain this velocity? And what did it mean for the future of space exploration and the possibility of life beyond our own planet? As Swift Delta continued its rapid journey through our solar system, something became increasingly clear. Its trajectory wasn't just a random path through space, but one that appeared to be remarkably deliberate. This object, moving 20 times faster than 3i Atlas, wasn't following the expected chaotic course of a typical comet. It wasn't being pushed off its path by gravitational influences, nor was it decelerating in the way natural objects usually do as they pass through our solar system. Instead, Swift Delta maintained a course that seemed almost calculated, precise, unwavering, and almost too perfect. To understand the significance of this, let's consider the way objects typically behave when they pass through our solar system. Comets, asteroids, and other interstellar objects that venture too close to the Sun often experience gravitational slingshots, where they are pulled or altered in direction by the Sun's immense gravity. They also undergo intense solar radiation, which can cause them to fragment or lose mass through outgassing. Comet tails are made of gas and dust expelled as the object's ice sublimates under the Sun's heat. Swift Delta, however, did none of this. Instead of fragmenting or losing material, it maintained its sharp structure and continued along its path with remarkable precision. It wasn't a fluke. Swift Delta wasn't tumbling through space in a random fashion. It wasn't a mess of icy fragments, shedding dust as expected. Its movement was calm, measured, and entirely different from the erratic motions we observe in comets. To astronomers, this was an extraordinary anomaly. After all, comets are expected to exhibit certain characteristics, namely, they should behave unpredictably when they interact with the Sun's radiation. Their paths are often bent by gravitational forces or altered by jets of gas and dust. But Swift Delta defied this. It moved through space with a level of control that was unprecedented for a natural object. In fact, its behavior suggested something almost engineered, as if someone or something was guiding it with an intelligence we had never encountered. There was no random deviation in its path, no signs of instability, just an object moving smoothly and precisely as it made its way through our solar system. It was as if Swift Delta was deliberately avoiding the chaos that would typically occur when an object passed so close to the Sun. Scientists began to wonder if Swift Delta was not just a cosmic visitor, but perhaps a piece of technology. The precision of its movement, the lack of chaotic outbursts, and the ability to stay intact as it passed through the solar system suggested that it could be more than a comet. Could it be an interstellar probe designed to navigate the vast expanses of space with advanced technology? The idea that Swift Delta might be a probe was first considered a far-fetched theory. After all, who could imagine an alien civilization creating a probe capable of travelling through the stars with such speed and control? But as the data continued to pour in, the idea started to gain traction. Swift Delta's behaviour was consistent, unlike any natural object we had ever observed. Its velocity, its trajectory, and its resistance to the expected forces of space all pointed to something far more advanced. And then, as if to confirm this theory, a group of scientists proposed an even more striking possibility. They speculated that Swift Delta's trajectory wasn't just random or natural, it was intentionally directed. The object's speed, its path, and its precise navigation through our solar system all seemed to suggest that it had been programmed to follow a certain route. What if it was a probe sent with a specific mission in mind? As astronomers examined its movements, they also noted that Swift Delta appeared to have made small, subtle course corrections. These tiny shifts in direction seemed to imply the presence of an onboard guidance system, something that could actively alter its path as it travelled through space. This wasn't just an object drifting passively through our solar system, it was responding to its environment in real time, adjusting its course and staying on target. If Swift Delta was indeed an interstellar probe, its precision would be a testament to the technological advancements of the civilization that created it. Its ability to travel at such speeds and remain intact, unaffected by the solar radiation and gravitational forces that would normally cause a comet to fragment, hinted at technology that was far beyond anything humanity had ever developed. But why had this object come to our solar system, and what was its purpose? These questions lingered as astronomers around the world continued to track its movement. Swift Delta wasn't just an anomaly, it was a sign that we were witnessing something far greater than we had ever imagined. The possibilities were endless. Was it a message from another civilization? A scout sent to gather data on our star system? Or perhaps it was something else entirely, a probe designed to travel the cosmos, studying everything in its path. As the mystery of Swift Delta unfolded, it became clear that we were not just observing a comet, but something that defied the boundaries of our understanding. Each new observation, each new piece of data brought us closer to uncovering the true nature of this extraordinary object, and possibly a glimpse into the future of interstellar exploration. As Swift Delta continues its journey beyond our solar system, one thing has become abundantly clear. We are facing a mystery unlike any we've encountered before. This object, moving at speeds 20 times faster than anything we've observed in the past, has not only defied our understanding of comets and interstellar objects, but it has also forced us to confront the possibility that we are witnessing something far more complex than a simple cosmic visitor. What began as an anomaly, an interstellar object speeding through our solar system at unprecedented velocity, has slowly evolved into something much larger. Swift Delta's trajectory, its ability to maintain such precision, and the way it seemed to interact with the Sun have raised more questions than answers. Could this object truly be a probe, a message from an unknown civilization? The signals, the way it responded to solar radiation, and the sheer control it demonstrated over its movement suggest that it might be something more than just a natural object. Could it be a piece of technology, created by an advanced species to travel the stars? Or is it part of something much bigger? Something we can't yet fully comprehend? The data we've collected so far, from its speed and course corrections to the possible signals it emitted, has shifted the way we think about space exploration. We are now asking questions that just a few months ago seemed impossible. Could we be looking at the first tangible evidence of extraterrestrial technology? Could this be a harbinger of something greater? We've always looked to the stars for signs of life beyond our planet, but until now the possibilities seemed far-fetched. Swift Delta's arrival has forced us to reconsider everything we thought we knew about the cosmos. As we continue to track Swift Delta, there is still much we don't understand. The object is now moving away from us, its journey through the solar system nearly complete. But the questions it has left in its wake will echo for years to come. What was its purpose? Who or what sent it? And perhaps most importantly, what does this mean for the future of space exploration? Swift Delta is not just a comet. It is not just a passing visitor from another star. It is a signal that there is more to the universe than we have yet discovered. And it is a signal that the unknown is much closer than we ever realized. The implications of this discovery are profound. It challenges everything we thought we understood about the laws of physics, about space, and about the potential for life beyond Earth. For decades, scientists have speculated about the possibility of extraterrestrial intelligence, but now we find ourselves faced with a potential reality. Whether Swift Delta is a natural object or an artificial probe, one thing is certain. It has opened a door to new possibilities, possibilities that we can no longer ignore. The universe, it seems, is full of surprises, surprises that are much more complex and much more interconnected than we ever imagined. As we close the chapter on Swift Delta's passage through our solar system, we are left with a sense of wonder and awe. We are standing at the edge of something monumental. And though we may not have all the answers now, this discovery has given us a glimpse into a future where the unknown is no longer a mystery, but an invitation. Thank you for joining me on this journey of exploration and discovery. As we continue to observe Swift Delta's path through space, and as we look to the stars for answers, we are reminded that the universe is vast, filled with possibilities that we are only just beginning to understand. If there's one thing we've learned, it's that the more we explore, the more we realize how much there is still to uncover. Don't forget to subscribe to stay updated on this ongoing mystery as new data continues to emerge, and feel free to leave a comment with your thoughts. What do you think Swift Delta is, and what does this discovery mean for the future of space exploration? As always, thank you for watching, and I look forward to continuing this journey together as we explore the unknown, one mystery at a time,